forward.
So our prototype design will be the same as our original design, just will be half-sized and using different material to minimize the cost. So the prototype, so when we have the prototype in our hand, we can test the quality of mixing because we have like two shafts rotating in opposite way, and we can also like estimate the angle of the blades. With that we can estimate the torque on the blades, and with that we can like calculate the power required for the shaft, and we can also test the flow direction if it's going forward to the Team2 subsystem, and also we can like estimate the length of the thread.
So some unexpected problems we had. The final design needs to be 6 feet tall, about, to make sure that we can get to other following systems. This makes it really top heavy, which means we have to have very reinforced beams holding it up that high. So Dave was talking about how it would be better if we use standardized beams across each team. So we talked with Team 1, and they were using these dimensions of angle irons, so we decided to run those and see how well they would hold up. And unfortunately, they didn't hold with the desirable factor of safety, and that was with 6 legs total, so 3 on either side. Now, the cost benefit of this is, do we want to add more legs, which would increase the amount of beams we would have to buy, or do we scrap these dimensions and do a larger dimension beam where we'd only have to use less than the legs? So we tried using 75, 56 millimeter angle irons. These worked, which was very nice, and on top of that, they were in metric scale, which is what they would be using in Uganda. So the conclusion is, as of right now, we're going with the 75 millimeter angle beams. Like I said, the benefit of it outweighs standardizing in our eyes.
So for the validation plan, actually, we're going to test how well the shafts are mixing the clay. And basically we are building the mixer using 3 materials. So we're going with a sonotube for the corners, and for the flat surfaces we are having it's gonna be built from oriented strand board.
Is that OSB?
OSB, that's shortcut. So, and for the shafts, basically it's gonna be from treated cedar, and the material we are mixing is going to be sand and dirt. Because actually we're going with sand and dirt because the clay is too dense for the blades to handle.
And that's just because we're going to be using the wood as the blades, and we don't think using super dense wet clay would be able to withstand force on wood.
And also basically for the the color, the resulting color of the material we are mixing should actually tell us how well the mixed material got mixed, basically.
So here's our rough bill of materials for the prototype. Like what was said before, we'll be using sonotubes, OXB, pressure-treated cedar for the shafts. And as you can see, the example we have here is square, and we figured a square shaft would be better for this application since it would be easier to mount these wooden blades to rather than a circular shaft. And that would cause all kinds of different dimensional problems for us, just to make it easier for us. And then lastly, we have these brackets here, which I'll get to in a sec. So to visualize, like we said, the sonotubes will be used for those soft bottom corners. The flaps will be OSB. Look here at the top view, the shafts running will be the 4x4s we're using. And then these brackets that we're using, our issue is connecting the OSB flatboards to the sonotubes, which are curved, and we weren't sure whether to kind of sandwich them between two brackets or kind of off-center them and use adhesives. So the idea of the brackets is to, like I said, sandwich them between the two pieces to hold them together. That's it. Questions?
So how long do you need your shafts to be?
We're scaling down to half size, so the 1-to-1 is 2 meters, so it will be about 1 meter. So the shafts will need to be 1 meter. I think we can buy one 4x4 in almost 2 meters, which means we're like 5.
Okay, that should be short enough. Because I was going to warn you that it might be very hard to find two long 4x4s that are straight enough to actually turn without binding or having to have like huge tolerances that won't actually work.
Yeah.
But that might be short enough, you'll be fine.
This is just a prototype. Why are you using pressure treated?
Say what?
Why are you using pressure treated wood? It's going to increase your cost. And
It was the cheapest there was as fence posts that were square. I mean, it was just a name. They had all sorts of decorative stuff, and once we started looking at other kinds of posts, they were round, which, like I said, would make things difficult for us.